Okay, so today I'm going to introduce a new topic which is multi-threading in Java. Okay, I will give you some introduction and also we will see some use cases. So before understanding about multi-threading, I will help you to get acquainted with some keywords. Okay, firstly we will understand what is the difference between program versus processor versus process versus unthread. Okay, so we are already familiar with this verse, but we have to ensure that we are familiar with respect to multi-threading. We know we are already familiar with this word, but we have to ensure that this verse needs to be familiarized with the in context of multi-threading. Okay, so let us understand what is a program first. Let us understand what is a program first. So anyone can say, if I ask you a question like what is a program, you can simply say that a program is a set of instructions. Right? A program is a set of instructions. For example, when you open your computer, right? So in your computer, let us assume that you have the Windows operating system, right? So it has the Windows OS has a lot of programs inside. So you have Notepad, right? And you also have something like the MS Paint, you have, MS Excel, right? Whatever you open, whatever icon you open is going to be a program. Because why we call it as a program? It will do some operations. It will do some operations. So they have written some lines of code. For example, let us say that this is a notepad. Okay, so it is a notepad, but behind the notepad there are some instructions written in some other language. We are not sure, right? And there are some instruction returns, and they have created they have given it in the form of icon, so that when you open notepad you are able to do something. It's a program. Like when you open MS Paint, you're able to draw something. It's a program. Like when you open something like MS Word, you're able to type something. It is a program, right? So one line answer I can say that a set of instructions written in any language and stored in an hard disk is called as a program. Okay. What about Java? What about Java? Let us say that you have a Java file class here and you have some instructions inside. Okay, this is also a program. This is also a program. But tell me one thing. You have how many? We have discussed 4 programs so far. One Notepad, Paint, MS Word, and Java class. Okay, so they cannot run by itself, right? Someone has to, execute this program. Yes or no? Hello, they will remain in your hard disk, but someone has to execute this, no? Only if you click on if you open notepad will get open. I mean the program will remain like a program, and it has no effect until and unless you open that program, right? So by default I can give one answer like, what is a program? Program is a set of instructions written in any language. Can I say program is a set of instructions? Okay, I will tell you why we are discussing all this. You will get much clarity. Program is a set of instructions written in any language. Written in any language. Okay, I can also say that it is not running, it is just a code. Can I say it is just a code? It is not even the running component. I can simply say that it is just a code. It's just a code, right? Now let us see. Let us increase the complexity. Now let us say that okay, I have just opened the notepad. I opened the notepad in my system, and okay, I have opened the what we call it as MS Paint. I have opened the WordPad, and I have also opened the Eclipse editor to write the Java. I have opened it. I have clicked on that. I have just opened it. Okay. Once you open this, Now the program is running now. Now the program has started running. When you have any program, when you start any program, okay, that becomes what? That becomes a process. Hello? Are you getting? When you start any program, that becomes what? That becomes a process. It is a running instance of a program. Okay? Anything you take, like opening a notepad or opening WordPad, opening MS Paint, whatever it is. Okay? It becomes running. Now, see, let us say that this is a notepad. Okay, process one is a running instance of notepad. You have just opened it. It becomes a process. And you have opened Paint. It becomes another process. And you have opened what? You have opened MS Word. It becomes another process. You have opened the Eclipse editor. It becomes another process. All becomes another process. Right? Once the process is running, you can able to do so many things here. Okay, in the notepad you can type some data. In the Paint you can draw some you can draw some circles, or you can draw some whatever it is, square, circle, whatever it is. And in the WordPad you can write an essay, and you have few additional features inside the WordPad, comparatively better than Notepad. In the Eclipse you can write the Java program. Yes. Okay, so now see, you have opened 4 processes: process 1, process 2, process 3, process 4. Don't you think that every process will be occupying some memory? Yes or no? Don't you think that every process will be utilizing some memory? Do you agree with that?
Yes, sir.
Process 1 will occupy some memory. Okay, let us say that this is your RAM area, right? The process 1, okay, process 1 occupies some memory, process 2 occupies some memory, process 3 occupies some memory, process 4 occupies some memory. Okay, let me put it like this: 1, 2, 3, 4. Okay, let me name it as P1. So we have opened, we are under the assumption that we have opened four programs, I mean 4 processes, right? So P3 and P4, right? Okay, each process has its own memory space and own resources, and at last each process will have at least one thread. Okay, each process will have what? Each process will have at least one thread. It can have many threads. Maximum it can have any number of threads. We are not sure about it, but it will have at least one thread. Now the question comes: what is a thread? Okay, thread is not a topic of Java. No, the thread applies for every process. It's not limited to Java. Okay, so each and every process will have a thread. What is a thread now? What is the question is, what is the thread? In Java, what is a thread that we have? By default, that is what? Main thread, right? Okay, you create it or you don't create it, by default it is available to us. Yes or no? Agree? Hello?
Yes, sir.
Okay, so these threads are used to what? What is a thread now? Now let me introduce them. We know, now we got to know what is a program. Now we got to know what is the process. Okay, now we will understand what is a thread. Okay, thread is the smallest unit of execution inside a process, inside any process. Thread is what? Thread is the smallest unit of execution. Okay? A thread is what? A thread is the smallest unit of execution inside any process. Okay, how many processes we have so far? So minimum how many threads we can definitely say that minimum how many threads will be there, since we have opened how many processes? How many processes are there?
4.
4 processes. So minimum 4 threads are there with us. Yes or no? Okay.
Yes, sir.
So now let us say that, okay, this is T1. Okay, for the assumption I'm taking, this is the T2. We are giving some names to the thread. This is the T3. This is the T4. So in your system, you have 4 programs. You have 4 programs. Programs are nothing but the set of instructions. It's very clear. And when you open each and every program, it becomes a process, right? Once the process starts, each and every process will have at least one thread, minimum of one thread. Depends upon the application that you're opening. It depends upon the process that you're opening. Okay, at least one thread. we are assuming that we have only 4 threads because we have opened 4 processes, and each thread will perform operation. Now the question is how these threads are going to perform the operations. Don't you think that, okay, by looking at this, can I say that our computer has opened, do you think that these 4 processor are learning parallelly or sequentially? What is your thoughts? What are your thoughts here? Hello? Okay, I will ask you, I will tell you one more, I will give you one more example. So we are human beings, okay? According to human, we are human beings. Human beings are, single threaded or multi threaded. For example, can we do multiple tasks at the same time through our conscious level? Do you think?
Yes, sir.
Can we through the brain, can we do multitasking at the same time? Yes or no?
Yes, sir. Yes.
What about others? Consciousness through the brain. Okay, I'm talking about the brain. If you have some time, okay, just do some research on this. Through the brain, can we do multitasking or not? That is the question. Okay, Sudhir has said yes. Okay, so strictly speaking, our brain is not multi-threaded. How the brain will work is, even though you are, for example, let us say that you are writing an essay, okay, and yes, essay, okay, you are, writing an essay, you are listening to songs, focus it, this will be interesting, and, parallelly, you are not scrolling, writing essay, listening to songs, and you are speaking to your friend. Okay, so we think that these 3 things are happening parallelly inside our brain. We are thinking like that. But what is actually happening is, okay, let us say that, okay, this is the, let us say that at any point of time, your brain, okay, at any point of time, your brain can concentrate on only one thing. Either, okay, let us say that the timestamp is like nanoseconds. Okay? Either it can focus on essay, right? Once, or it can focus on listening songs, okay, or it can focus on this one, speaking to your friends at any point of time. It happens so fast that you will get an illusion like, okay, it is happening parallelly. It happens one after another at any point of time, but not, brain cannot process all the activities parallelly. You know what I mean? Brain cannot process, okay, simultaneously you cannot speak to your friend, or you cannot listen to your songs, you may be feeling, that is an illusion. You may be thinking that you are doing all these things together. Now I am speaking, okay, I am also drawing, I might be thinking that I am doing it together parallelly, but it is not. It is happening concurrently. At least have we got some minimum idea what is it is happening? What is a concurrently? Are getting minimum idea? Hello?
Yes, sir.
It is not happening parallelly, it is happening one after the other, but we are under the illusion that it is happening parallelly, but it is not. Okay. There are some places it is happening, parallelly. I will tell you that. First of all, let us understand what is this. I have used some word for concurrently, or it is happening because of what? Concurrency. Now we will understand what is the word concurrency. It applies to any programming language, not only Java. Concurrency. Concurrency means nothing but, see, how many processors are running in our system? 1, 2, 3, 4. 4 processor, right? 4 processor, and each and every processor has one thread, one individual thread, right? So in our CPU, okay, during 1990s, 1980s, most of the CPUs are single, they use the single core processor. What is it? They use the single core processor, which means you have 4 programs running on your system. Each and every program has one thread. Okay, let us say that the threads are like, okay, this is the P1 thread, okay, and this is the, okay, P2 thread, Okay, this is the P3 thread, and this is the P4 thread. Okay, we have four threads. So this is not P1, let us say T1. T1, T2, T3, and T4. Okay, but your computer processor, your single core processor, okay, they can process minimum of only one task at a time. Okay, a time slice will be applied. Let me repeat this. A kind of time slice will be applied by your operating system, whatever the operating system that you use. Time sliding is nothing but a minimum amount of time. Let us say that 20 milliseconds or 20 nanoseconds, minimum amount of time. Time slice is a minimum amount of time where each and every thread will get an opportunity to execute the instructions. Minimum amount of time. Okay, your single core processor will, will execute the threads in such a way that each and every thread will get this minimum amount of time. The time slice we call it as. At any point of time, T1 will be executing for 20 nanoseconds and it comes back. T2 gets executed for 20 nanoseconds, it comes back. T3 gets executed for 20 nanoseconds, it comes back. And T4 gets executed for 20 nanoseconds, it comes back. And the round robin happens. It happens so fast that you will be under the illusion that all the four programs are operating parallelly. Are you getting this or not?
Yes, sir.
This is called concurrency.
Yes, sir.
This concept is called as what? The concurrency. What does the concurrency means? Concurrency in not only in Java, it applies for operating system, it applies for Python, whatever the language that you know, it applies for all the programming languages. Okay, is what when multiple, when multiple process, what is it? Process, right? When you are executing multiple programs, okay, multiple process gets created. Okay, it will ensure that each and every process will get a time slice to execute the instructions. Okay, the single core, the CPU will do that, or single core, let us say single core. The single core processor will do that in a fast way. It will give an illusion that everything is what? Everything is running together parallelly. Now we are in a position to understand something about what is process, something about thread, something about program. Yes or no? Hello?
Yes, sir.
Yes, sir.
Now let us understand this about the processor. What is the processor, sir? Okay, what is a processor? It is a hardware. Okay, what is a processor? It is an hardware that execute what? That execute the programs, that execute the threads. Like I said, we are talking about the single core processor now. Yeah, single core processor. This is a processor. This is an hardware device that will execute what? That will execute programs. Okay, that will execute programs and that will execute the threads. It will be able to run the task sequentially in such a fast way by using a time slice where you will not even know that you will be under the illusion that everything is happening parallel. Processor is nothing but the hardware where the program gets executed. As simple as that. Are you getting this? Now we got completed of what is a program, processor, process, and thread now. Hello?
Yes, sir.
Okay. Now, sir, we are good about the concurrency. We are good. Okay. Then what is the, see now we are using some much more advanced systems, right? So now the systems that we are using, so it is what? It is quad core systems, okay? Quad core processor systems. It means also called as what? Multi-processor system. What is it? Quad core. Quad core. So let us say that you have a quad core laptop, which means you have multi-processor. For the simplicity, I am taking, instead of a single processor, let's say that we have two processors. Two core process, two core. Not single core, we have two core. Okay, let us say that you have the four threads. Okay, if you have only one processor, so don't you think that T1, T2, T3, T4 will get its turn to get executed? Each and every thread will get, but at any point of time, only one thread is going to be participating in the core. Yes or no? Single core.
Yes, sir.
Single.
Yes, sir.
Okay, but in the multi-core, now you have one more core, isn't it? Now, if you have four, don't you think that at any point of time, two threads are going to get participate at any point of time, T2 or T3, whatever it is, at any point of time. Here, at any point of time, only one thread will be participating, right? But when you have two cores, at any point of time, two threads gets participated. If you have three cores at any point of time, I'm talking about any point, any point, any point. Any point. Okay, at any point of time, let us say, okay, let me keep it more simple. Let us say that we are only talking this with respect to the Java program. Okay. Let us say that our Java program has 5 threads. If it has 5 threads, okay, if I am using the single core processor, at any point of time only one thread gets only one thread will be participating to execute instructions. Yes or no? At any point of time, only one thread will begin in the single core. But in the dual core, at any point of time, two threads gets participated. Dual core. Okay. So in single core, it is always concurrency. Talking about the concurrency. Concurrency means all the threads will get a chance after a time slice. It happens so fast. It is not like, for example, when you're visiting a supermarket. Okay, let us say that in the supermarket, accountant as well as the sales representative and the what do you call it, the security, everything is every job is done by only one person. Don't you think that if 100 persons are visiting the supermarket, okay, let us assume that if if only one in charge is taking care of accountant as well as the sales acting as a sales representative as well as acting as a security, okay, he will ensure that each and every person job is completed, then he will allow the second person, and the line will be very much huge, right? But there will be no customer satisfaction here, right? Likewise, when you open a computer, you are opening an MP3. Let us say that your computer is allowing you to open another application only after completing listening your songs. Will you be satisfied? Hello?
No.
Let us say that you open Java program. Only after completing Java, you are allowed to listen songs. Only after completing listening songs, you are allowed to watch a video. You will not get satisfied, right? How to make you satisfied? So touching each and every program parallelly. Parallelly, it cannot be achieved by using single core, but it is super fast that, okay, you will get an illusion that everything is happening parallelly. Because it is what? It is giving the huge amount of satisfaction, but internally, it is what actually every thread or every process is getting a small amount of time. It is happening so fast that you are under illusion that it is happening parallelly. But it's not parallel operation, it is a concurrent operation. Parallelism means, let us say that when two threads are participating, okay, T2 and T3 at a given point of time. Okay, this is called as what? Parallelism. This is called as what? Parallelism. Very simple. When more than one thread is getting a chance to get executed at the given point of time. Parallelism. But strictly speaking, even though if you use dual core or any number of cores, definitely there will be a combination of concurrency and parallelism, but not 100% parallelism. Are you getting? Because there will be huge amount of threads. You can see concurrency plus parallelism, or you can see only concurrency, but you cannot see only parallelism. Are you getting what I'm trying to say? Because there are so many threads. So what they have done in 1990s, 2000, right? So they did not develop the multi-core processors. Instead, they made the single core processor very much robust. Means the CPU started executing each and every thread in in less than nanoseconds. So fast. Okay. So for example, let us say that if this is your process, this is the single core processor. Okay, the instructions are executed so fast. Okay, so each and every instruction gets executed so fast. Okay, it looks like the performance is very much each and every executed instructions will use this processor so fast. It looks like the performance is very low. So do you know this? When you see, if you are an electrical engineer, you will be knowing this. Frequency. Do you know about this frequency? When 230 volts. Is anyone from electrical?
Yes, sir. I'm familiar.
Sine waves, cos waves. So every second, okay, there will be huge amount of fluctuation. Do you know that? The light will be blinking
Yes, sir.
so fast that it looks like it is not even blinking. Yes or no? Hello? The bulb will be blinking, okay, for alternate currents. The bulb will be blinking so fast that you won't realize that the bulb is actually blinking because the blinking is happening so fast. Likewise, if all the threads are getting changed so fast, you won't be feeling like it is concurrency, you will feel like it is happening parallelly. Because of this, what happened, okay, the it generates lot of heat will get generated. Sometimes you might have to end up losing the hardware setup. Okay, then they have started introducing what? Then they have started introducing the dual core system. 1 minute. Hello? Class one.
Yes, sir.
Understood everyone?
Yes, sir.
Okay, now let us jump into the topic. Now we have understood
Yes, sir.
what is parallelism, we have understood what is concurrency, some idea we got. Okay, so what is concurrency? Now you are in a position to tell what is concurrency. Concurrency is what? Multiple tasks making progress at the same time. Progress at the same time. See, a lot of difference is there. If you just remind this difference, you can understand this difference. Concurrency. Concurrency, parallelism. Okay, what is concurrency? Multiple tasks. Okay, you talk about multiple tasks for both concurrency as well as parallelism, but about the execution, multiple tasks makes progress at the same time. Okay, what is parallelism? Multiple tasks executing at the same time. Understanding the difference here? Hello?
Yes, sir.
Yes, sir.
This is always single core. Okay, and this is what? Sometimes it can be multi-core also. You cannot come to a conclusion. Sometimes it can be multi-core also. In the multi-core also concurrency will happen. Okay, but it is always multi-core. Multi-core processes. Okay, here single core is doing what? The operating system is taking a time slice for each and every thread. For instance, let us say 20 nanoseconds. It takes time slice. Okay, but there is no such concept of time slice here. It is truly simultaneous. Okay, when you have 10 threads, okay, each and every thread each and every thread will be given 20 nanoseconds. It will get its turn again. Right? Each and every thread takes 20 nanoseconds and it gets its turn once again. Right? But here, there is no such thing. Right? There is no concept of time slices. Okay, the threads are running simultaneously. 10 threads means 10 threads runs almost 90% or 80% of threads will run simultaneously. Understood? concurrency and parallelism?
Yes, sir.
Yes, sir.
Okay. Now one more thing is here. Okay, so we have understood this. We save file, save as PNG. Now, so who is giving the chances to these threads that we will understand in the coming topic? Okay. Now I will give you one in Java. Let us come and discuss this in Java. Let us say that we have a Java program. A Java program. Okay, let us say that you have a class A, and inside this you have many instructions along with the main method. Okay, you have the main method. Let me take the main method also. So you have many number of instructions. Okay, you have the thousands or tens of thousands of instructions. Okay, so you do not want to depend upon the main thread. Okay, so main thread is a default thread that is responsible to execute the instructions which you want to execute. Main thread is responsible. Always a main thread will be there. It is a default thread. But let us say that along with the main thread, you are also creating, let us say you have main thread, and you are creating, okay, you are creating three more threads. Main thread is a default thread. You have an option to create three more threads so that you can share what? You can share the work to remaining threads. You can share the work to remaining. Let me tell you, okay, along with the main thread, you have thread 1, T1 and T2, T3, right? When you start running all the threads, there is a concept called, the thread scheduler. Thread scheduler comes into the picture. Now the question is what? What is this thread scheduler, right? Okay, this thread scheduling with respect to Java, it is maintained by your operating system plus your JVM. Let us say that this is your operating system, this is your JVM. They work together to enforce the thread scheduler. They work together to enforce the thread scheduler. Now, what is this thread scheduler means? Okay, this will decide which thread has to run and for how long that thread has to run. This will decide. This thread scheduler will decide. Okay, the programmer has 4 threads with him. The programmer wants to execute a particular Java program, and along with the default thread, he has also created, 3 other threads, user defined threads. Okay, which thread will give a chance will be decided by what? Will be decided by the thread scheduler. Thread scheduler is part of what? It is part of what? It is controlled by the operating system along with your Java virtual machine. It is part of your operating system, or it will be controlled by your operating system along with your Java virtual machine. This thread scheduler will decide which thread has to run, not the developer. Okay, the thread scheduler will say, okay, main thread execute some instruction in the concurrent level. Again, in the concurrent level. Concurrency means, let us say that it is a single core or multi-core, whatever it is. Since we are talking about least number of threads, let me take, we have only 2 core processor. Okay, this thread scheduler will decide, okay, main thread, please, start executing. Along with the main thread, it will also give you a chance to another thread, please start executing. Okay, for a certain amount of time. For how much time? For a certain amount of time. That is called as what? The time slice. What I'm trying to say, you don't have any control to give instruction to thread, for how long it has to get executed. The priority you can also set priority. You have the control of setting the priority. Priority means like you can say in Java you can write a code saying that my thread 1 should get first priority, my thread 3 should get the third priority or second priority, my thread 2 has to get the third priority. You can set priorities, but you cannot decide what the how long the thread will be executed. Even though if you set priorities, the thread scheduler will listen to you or it will not listen to you. It's up to it, because internally it's an internal program design. It's not only uh, decided by JVM. Okay, JVM should also interact with the OS. The decision will be made by both. Even though Java gives you an option to set priorities, that may not work sometimes, because it is in the control of both operating system as well as JVM, not only Java. Are you getting what I'm trying to say? Hello?
Yes, sir.
Okay. So thread scheduling is a kind of topic where it will work on what? Okay. Sometimes it works on the round robin mechanism. What is round robin again? Okay. When you created T1 first, T1 gets priority. And priority means T1 will get a chance to execute its instructions, followed by T2, followed by T3. Again T1, T2, T3. Okay, this will be executing like this. T1, T2, T3, again T1, T2, T3, like this. Execution will be like round robin. I can put it like this. You execute it like this. This is the default setup of thread scheduler, like a queue. First in first out, you can say. First come first serve. Okay, this is called was what? This will be taken care by the thread scheduler. But in some cases, if you are setting up the priorities, okay, the JVM will listen, but may not will listen. Operating system may not listen. Sometimes JVM will listen, sometimes operating system may ignore that. Even it will not give you a guarantee that which thread has to get executed. We'll see these things programmatically. First of all, we have to understand what is a thread scheduler. Okay, scheduler, what? It decides which thread should run first. That's it. It is a decision maker. Thread scheduler is nothing but a decision maker. That's it. We will give it very simple. It's a decision maker. Which thread should run first and which thread should run last. That's it. Hello?
Yes, sir.
Yes, no? All the jargons are clear, no?
Yes, sir.
Okay. Now the last jargon is context switching. What is it? Context. Now see, this is a very beautiful concept. Okay, let us see that we are working with the two different applications. One is the notepad. Okay, my notepad has let us say that it has only 4 instructions, and one is notepad and the second one is the wordpad. Wordpad also have only 4 instructions. Let us say that my notepad as well as the wordpad. Okay, this is notepad and this is wordpad. Both, each and every application has only one thread. Okay, default thread. Okay, only one thread. This is the here one thread, and here let us say that the thread has not one thread. Okay, context switching says that okay, it is a process. Okay, it is a process where the CPU switches from executing one thread to another thread. Let me say, for example, okay, let us say that this is your single core processor. Single core processor. Processor is single core. Okay, let us say that the name of this thread is something like T1. Okay, this name of this thread is something like T2. Okay, so whenever the T1 is getting a chance inside the single core, okay, for some time, that some time is ensuring this thread to execute 2 lines of code. It can be not only execution, It can be, you can be writing something, or you can be reading something, you can be deleting something. Whatever the task that you are performing inside Notepad, that is treated as what? That is treated as an instruction or an execution. Say that this is allowing you to what? It is allowing you to, this time is allowing you to execute these two instructions inside the Notepad. Right? Then it comes out. T1 comes out. Now T2 get a chance. Now T2 gets a chance. Okay. Let us say that T2 has utilized its time to execute only one instruction. Okay. And it comes out of this. So are you seeing that one thread, two threads are taking what? Two threads are taking chances here, or they are getting tries here. Right? One thread is executing instructions while other thread is remaining idle, and again other thread comes into the single core and the other thread is remaining idle. The switching is happening. At the time of switching, each and every thread will remember its state. This is the important term. Each and every thread will remember its state at the time of coming out of the processor. For example, when 3.1 is inside the processor, inside the single core processor, okay, at the time of coming out, the thread will remember the state where it has stopped previously. That is the state. Likewise, when 3.2 as coming out of this core, this will remember this state. This is called as what? This is called as the state. State means the memory, last executed status. Are you getting what I'm trying to say?
Yes, sir.
Okay, and again when the T1 is getting chance, now it will remember that okay, the last executed state is over here. It has to continue from the next line, right? Again, while it is coming out, it will remember this state. This is the state it will remember. Okay, now T2 gets chance. Same thing happens for T2. This is called as what? Context switching. Context switching is a process where CPU switches from executing one thread to another thread, or executing one process to another process. During this time, okay, the CPU saves the state of the current thread. CPU saves the state during the switching. 1 minute, guys. One minute. CPU save the state during the switching. Getting this? What is context switching? I'm giving you what is what. That's it. Again, we will revisit this topic once again, because you should not be in a position, when I introduce that words, you should not be in a position to not to grasp. Understand that? Are you getting? Hello?
Yes, sir.
Yes, sir.
Now we are completely perfect with what is a process, what is a processor, what is a program, what is a thread, what is the thread scheduler, what is context switching, what is concurrency, and what is parallelism. Right? Everything is fine. Everything is fine. Now the question is, with respect to Java, what is a thread? We know what is thread now. With respect to Java, we have to understand what? We have to understand how to create a thread in Java. Right? Very easy. Okay. Very easy. How to create a thread. The first thing is, you can create a thread in Java. Create any class. You can create any class that should extend what? That should extend the thread class. I will repeat. Thread is nothing but thread is a class in Java. Okay, how to create a thread? You can create any class. Let us say that I am creating a class like account class, whatever, student class. Okay, create any class that has to extend what? That has to extend the thread class. The first way. Okay, this thread class, okay, thread class internally as a method called run method. Thread class as a run method, and that run method needs to be overridden. It needs to be overridden. This first way, under the first way, okay, I'm just giving you what is a thread. Thread is a class in Java. Okay. First point is what? Create any class that extends the thread class. Thread class. This is the simple syntax. Second one is, please ensure that the thread class has a method called run method. Okay, your class needs to override that run method. Right? The third point is create an object of your class. Fourth point, and call the run. Remember these 4 points. Remember this. Create any class. Let us go by one. Create any class. Okay, let us go to the code. I have a class called driver class. Let me create my own class. Okay, account class. Okay. Only creating class is not necessary. This should extend what? This should extend the thread class. Again, the thread class is the Java part of java.lang package. By default, is part of what? Java.lang package. Is part of Java package. Right? Create any class. What is the second point? Second point is what? You need to override the run method. Okay, run method is part of the thread class. You do not want to depend on the thread class run method. You need to override them. Okay, I'm just overriding it. Run method. Okay, this thread class has also a run method. When I open the declaration, you will see the thread class has so many things. One of the thing is you will find the run method. Run method. You do not want to use this method. You want to override them. Okay, you're overriding them. Inside this, you can place any instructions where you want to achieve the concurrency, which means, see, in the main thread you can have some instructions, right? So wherever you want to, ensure wherever you want to achieve the concurrency, means some instructions needs to be executed by your own thread. Place those instructions inside the run method. For simplicity, I am running a for loop. Integer I equal to 0, I is lesser than or equal to 10, I plus plus. This is an instruction. I just want to print what? I just want to print the I. So this is a for loop which is part of the run method. But I do not want to execute this run method by the main thread. Are you getting? Whatever the logic or what are the instructions that you want to execute it by using a new thread, not the main thread. You have to place those instructions inside the run method. Are you getting what I'm trying to say? Can be any instructions.
Yes, sir.
Okay. Now, what is the third point is clear. Overridden. Okay. And create an object for your class.
Yes.
What is the class name? Account, right? Account ACC equal to new account. After creating an object, what you are supposed to do? And call the run method on the object reference. Okay. Now let me call the run method. Account dot. If I run this code, you would end up seeing something. 0, 1 to 10 is getting displayed. But what is actually behind the scenes, I will let you. Okay, let me move this code to the main brush. Now anyone tell me what JVM will do? You know, compilation will happen. After compilation, JVM will come into the picture, right? JVM is going to create which thread?
Main thread.
Main thread, no? Main thread will be created by the JVM. Okay, JVM will try to access all the instructions inside the main method, yes or no? Let us say that this is the main thread, right? Main thread. Okay. The main thread. Okay, and it has found an object is getting created. Okay, an object is getting created, and the reference variable is what? Reference variable is ACC. So far clear. Okay, and you are calling the, I will focus on this one. You are calling ACC dot run method. ACC dot run method, right? Now this will not go here. This main thread will not go here. This main thread will not go here. What is actually happening behind the scene is here a new thread will be created. Main thread will stay here. You are calling the run method. Okay, and on which reference you are calling the run method? On the ACC reference. Okay. Account class is not an ordinary class. Account class is a class that gets an eligibility. What kind of eligibility? Okay, you can create a thread on to run any of the instructions inside the run method. Okay, account class is setting thread class, which means this account class has some set of instructions that can be executed by new thread. Okay, let me go back. Okay, I am not supposed to call the run method. When I just calling the run method, typically this will get executed. Which means main thread will only execute this. Main thread will only execute these instructions. But instead of calling the run method, I will be calling another method here. I won't be calling run method here. Instead of calling run method, I will be calling another method. Focus it. ACC.run, right? I will call start method. Is there any start method inside this account class? Anyone?
No, sir.
Okay, now let me run this code. If I am calling any method that is not part, definitely we have to get error. Right? I am calling the start method. Start method is not part of the account class. Oh, okay, it will go and try to find in the thread class. I mean, the thread class may have run method. But we have overridden that. The start method will try to identify, is there any run method inside this account class? Is there any run method? You have the run method. Okay. To execute this run method, the run method will be executed at this time. Now this is not run. Okay. You are calling ACC.start method. ACC.start method. Okay. Now the JVM will know that, okay, the developer is trying to create a new thread because he is starting a new thread. He is calling the start method, which means the main thread will give a birth to the new thread, and this thread is going to be something like T1. Okay, now this T1 will look for the run method inside the class, and this T1 is responsible to execute these instructions, not the main method. Are you getting what I'm trying to say?
Yes, sir.
So to understand this better, what I can do is, okay, if you have started, okay, I am also placing few more instructions here. I'm having another for loop here. Okay, so for the simplicity, okay, what I am trying to do here is, I just want to check which thread is calling which one. I can use a method. I mean, I can call a method like thread dot current thread dot get name. Okay, this is the code to get to know which thread is operating this, which thread is executing this instruction. Okay, let me run this. Are you able to see thread 0 is the thread that you have created, that is executing this. Okay, main thread is executing this. Or else, let us say that this for loop is for part of the main method. Okay, and this for loop is part of the user defined method. Let me run this. User defined method is executed by thread 0. Thread 0 means user defined thread. Main means main thread. Are you able to see the difference? Which instruction? Hello? These instructions are, this for loop is executed by the thread that you have created. These are executed by the actual main thread. So what is actually happening behind the scenes? Let me show this. Let me demonstrate this. Right? You know, now see that starts from the main thread. Okay, main thread gets access to the main method. This is the first instruction. Object will be created, no issues. Okay, after this it encounters the start method. The moment it encounters the start method, okay, it will check is there a run method inside the account class. So there is a run method inside the account class, right? It will understand that the developer is trying to execute the instructions inside the run method by creating a new thread. From here, a new thread will be born, okay, and this new thread will take care of executing this for loop, and the main thread will take care of executing the remaining for loop. Main thread, this is what? User defined thread or T1, whatever it is. Okay. So now what is happening? You are seeing the output. You are not seeing the mixed outputs. You are seeing the outputs like the user defined thread is executing first and the main thread is executing other one. Why it's happening means in your processor, okay, first T1 is getting chance. T1 is getting chance in your processor, in your core. Okay. The time slice is so fast that, okay, when the T1 is getting chance, the time slice is so fast that all instructions are getting executed. And again, T2 is main thread is getting chance. Time slice is so fast that all the main thread is getting executed. Are you getting what I'm trying to say? That's why you are seeing the output line. See the output. You should be getting the mixer output. Because my system is some operating systems are so fast. Let me execute this one second. Okay, now you see are able to see the mixer output. First, these two instructions. Okay, now time slice is coming in the picture. Okay, thread context, what we call it as, we have just discussed it now. Hello.
Yes, sir.
Main thread is getting a chance, then T0, then main thread T0. You see this output, what is internally happening is two threads are playing a role parallelly. Okay, T1 is getting chance. When T1 is getting chance, it is executing instructions as much as it can. And again, main thread is getting chance. It is executing instructions as much as it can. And again, T1 is getting chance. We are executing as much as it can. And again, main thread. Okay, the thread switches are happening so fast. Okay, the thread switches are happening so fast, right? You are seeing the output in the mixed order. Getting this? Yes, no.
Yes, sir.
Yes, sir.
Yes, sir.
Do you see? It is a what concept it is called as what? This contest we are achieving not parallelism, guys. We are achieving what? The concurrency. What is it? Concurrency. Java, it is always what? Concurrency. There are places where you achieve parallelism also, but most of the time it is concurrency. Two threads are not getting a chance to get executed parallelly. We are not sure. It may be getting a chance. We are not sure about our operating system. We are not sure about our operating system. Okay, based upon output, we are just guessing. If it is coming parallelly, see now again mixed output. Mixed output. Ideally, when you are creating more threads, they are not working parallelly. That is the intention. They are working concurrently, one after the another. Are you getting? Let us
Yes, sir.
please rejoin if you just knocked out of the meeting room. What we can do? Thank you for rejoining. See, let me place something like thread dot sleep. Let me place 2000 milliseconds here. Okay, and also place 2000 milliseconds. Are able to see it in the slow motion?
Yes, sir.
Two threads are working together, but not parallelly, but concurrently. You're taking some time. But if it is happening so fast, we will be under the illusion that things are working parallelly, but it is not correct. You can do a lot of wonders with see, only if the main thread is doing all the job, right? Only if the main thread is doing all the job, okay? It means we have to wait until one after the another. It means we will not get satisfied because some tasks will be taking a longer time. Some tasks will be completed in a short period of time. When you apply concurrency here, when you create new threads here, everything will be working concurrently. The small task will be completed before the big task. So there you see some kind of what? Some kind of some kind of satisfaction that performance is being looked upon. You think that performance is increased. Okay, that's why you always create what? You always create multiple threads to distribute the tasks concurrently. Okay, this is one of the ways. Okay, I just want to tell you the another way. First way is by creating the thread class. Okay. Second way is what? Second way is by extending to the runnable interface. Second, last way. Extending. What is this extending? Same thing. Create a class. Now this time that class needs to implement what? Implement runnable first. Okay. Create a class. Okay, we have the class created already. Okay, now implement this to runnable interface. Okay, runnable is an interface. You need to override the abstract methods, right? You have only one method, run method. You are just overriding them. Inside this, you give the instructions. Okay. Let me remove this. Okay. So run method as this instruction. This time you are not extending the thread class. You are implementing with runnable interface. Okay. Next step is override the run method. Okay. Third one is you need to create a thread class object. Create a thread object. Okay. The main method. Okay. First you do what? So create the reference for runnable or rt equal to new account. Interface reference the class variable. After this, create the thread object equal to new thread. You can pass the reference of runnable interface. Pass the reference of runnable interface. Now you call the t1.start. Okay. So here I'm implementing with runnable interface. This is second way of creating that. Either you can extend to thread class or implement runnable interface. When you implement runnable interface, you need to override the abstract methods, right? So run method is an abstract method that is overridden here. Inside this, you will place an instructions where you want to execute these instructions concurrently, where you want to create your user defined thread and execute these instructions. I'm giving a simple for loop. After this time, okay, you have to create an object for the runnable class. Runnable interface. You don't create an object directly because not allow you to create an object. with the account object, you keep that with the runnable reference. Then you have to create the thread class. Inside this constructor, you need to pass the reference of the runnable interface. Then on this, you can call the start method directly. Okay, from here, a thread will be created. New thread will be created. New thread will take care executing the instructions inside the run method. Okay, and if you have any remaining instructions, that will be executed by what? That will be executed by the main method. This will be executed by the main thread. New thread will always be started from the start method one. New thread will always be born from the start method one. These are only two ways of creating a thread. Why they have given this option is, why they have given runnable option is very simple. Sometimes, do you think multiple inheritance is possible in Java with classes? Hello? When a class is extending to another class, for example, when class A is extending to class B. When one class is extending to another class, do you think that you can extend to thread class here? Is it possible to extend to thread class again here?
No, sir.
There is a drawback, no? To overcome this drawback, they have given the second option, which means if your class is extending to another class, you do not have the chance to extend to thread class. Instead, you can implement to runnable interface. Are you able to see the difference? There is a
Yes,
drawback with the classes. Why? Your class might have been extending to another class, so you cannot extend to thread class here, right? Multiple inheritance is not possible. One class cannot extend to both classes. Okay? To overcome that, they have introduced this, which is what? If your class is extended to any other class, no worries. You can expand. You can implement the runnable interface. You can also implement multiple interfaces. No issues, no. You can implement multiple interfaces, but not the classes. Okay? But in the project level, this is always recommended. The real-time application, you implement the runnable interface, because each and every class in the real-time applications will not be ideal, will not be standalone. It will be a child class or it will be a parent class. Okay, you will not get a scope to use the thread class. That's the reason why. Most of the real-world applications will use what? Implement runnable interface. The second step. Understood?
Yes, sir.
Are you finding this